welcome back to ExpertFunda. So today we are going to solve this problem 3129. It's saying find possible stable binary arrays 1. Okay, so the question is very fantastic. It's based on DP. It's very interesting problem because this is based on dynamic programming problem. So this will help you to understand the concepts, right? So in this problem we need to count how many binary arrays are possible, but there is a twist. The twist is we cannot place too many identical numbers consecutively. So the real question becomes, how do we generate all valid arrays while respecting these limit constraints? So let's break it down this problem in very simple terms so you will understand clearly. Okay, so the question saying that the question saying that you are given three positive integers, that is 0, 1 and limit, right? Three things you have given. As you can see, 0, 1 and limit, three things you have given. Then it is saying a binary array is called stable if the number of occurrence of 0 in the array is exactly 0, the number of occurrence 1 in array is exactly 1, each subarray of array with a size greater than limit must contain both 0 and 1. And then it becomes, if that is the case happening, that is called a binary array, a stable we can say, and we have to return the total number of stable binary arrays. If these things happens, that becomes that becomes the stable binary array, and you have to find total number of stable binary arrays. And we have given this constant we have given, so based on this constant when we return, you have to take the modulo. That we will understand clearly in this video. So let's break it down. The very first thing that we have given three things, that is 0, 1 and limit. 0, 1 and limit, three things we have given. So where will we use 0? 0, it is saying that number of 0 we must use. How many of 0 we have to? Number of zeros that we have given. Number of zeros we have given is 1, means 1 0 we have to use here, right? If you will not use 1 0, means that is not beneficial. That is not based on the question. It is saying that, okay, means you have to use that. Then we have this 1, means the number of ones we must use. We have to use this number of ones, number of zeros that we have given. Here we have given 1, means 1 0 we have to use. We have given number of 1 is 1, means 1 we have to use. Then we have limit. Limit is the maximum number of consecutive identical elements allowed, means maximum number of consecutive elements allowed is what, which is identical, is 2 maximum. So this is the question saying that. It means what? We must use exactly 0 number of zeros we can say, right? And we must use exactly 1 0, means exactly 1 number of 1s we can say, and we cannot place more than the limit, that is 0 and 1, right? So such arrays are called stable binary, what we call stable binary arrays, or you can see here stable binary arrays we can say that. So this is what we have to do. We will understand further. Let's go to the board, you will understand. Okay, so let's try to understand the problem that we are understanding here is Leetcode 3129 we are going to understand. Okay, 29. The very first, let's take an example. Okay, we'll try to understand through the example. Okay, so the input that we have given in this example is what? Very first we have given 0, so 0 is given is 2, 1 we have given, let's suppose, is 1, and let's take limit. The third thing is limit, which is 2 we have given. Okay, so this is what we have given as an input. Okay, so we must create the array using these things. Let's we'll create an array, right? So 0, 0 and 1, I'll take these things. Now let's generate all possible permutations, right? The first possibility is, right, what we are going to do, we want to generate all possible, the permutations means possibility. Permutations is nothing but, guys, possibilities. I know that you have gone through these things in the elementary schools, right? But if you have any doubt, you can ask me here. So let's talk about the first possibility. Okay, What is the first possibility here? Let's think that we have 0, 0 and 1. This is the very first possibility we have. Means here we have two consecutive zeros. This and this. Two consecutive zeros we have. What we have? Two consecutive zeros we can say. Right? If we have two consecutive zeros, since our limit is what? Our limit, since our limit is 2, that you know, right? If our limit is 2, means maximum zeros allowed is 2. So this is the array, valid array we can say, right? It's called a valid array. Okay guys, if any type of mistake is there, excuse me. Okay, let's think that what is the second possibility. Let's talk about the second possibilities. What is the second possibility? Let's think. First we thought that it's 0, 0, 0, 1, right? Let's think now. The second I will think if we can use two zeros like this between 1, right? So here there are no more than one consecutive numbers, right? But this will also be valid, right? Right? Two consecutive zeros is not there, but one consecutive number is there, right? So that's also fine. Let's talk about third possibility. Third possibility. Okay guys? Okay. Think that this time we'll take 1, 0, 0 like this. Is this valid? Again, we have only two consecutive zeros, which is valid here, right? Which is allowed, right? So this is also valid. I hope you are understanding. In this case, we saw that total 3 possibility we found. Possibility 1, possibility 2 and possibility 3. The very first possibility is that 0, 0, 1. It is also valid because two consecutive zeros are there, right? The second possibility we have seen where we have took two zeros between, there we have taken 1. So this is also valid. Third possibility that we have chosen that is 1 and then 0, 0. So this is also valid. And so we can say our answer here is 3. So total 3 valid answer we have here, right? What are the answers are there? We have took 0, 0, 1, 1, 0, 1 and 1, 0, 0. So these 3 are the binary stable arrays we can say. These are we have for this input we are talking about, right? For this input, this is the upper input that I'm talking about. For if the input we have given is we need 2, 0, limit is maximum 2 consecutive will be 2 and there will be 1, exactly 1, 1 we have to use. So if you see in all we have taken only 1, 1, right? But 0 we have to get two times, right? Because 2 zeros are allowed. That is our limit we have given. Okay. Now let's understand the main thing that we should understand. Okay. What are the observations we have seen here till now that we should understand? The key observation we can say. Okay. Ready? So instead of generating all array blindly, right? That we are doing here, we are generating this one, this one, this one, right? So instead of generating all valid array blindly, we should think carefully, right? And what you will think? While building the array, we must track some of the things, right? Let's think that what are the possibility that we can think, right? So the main thing is that we don't want to generate this array, correct? Then what we can do, right? If we cannot generate this array, then what we can do? There is many possibility things that you can do, right? What are the possibilities are there that we are going to talk about, guys? Okay, let's think that while building the array, we must track what, how many zeros remain, correct? When we will think that while building the array, we must track the first thing is how many zeros are remaining, right? Then how many ones remain, can we say that? Then the last element placed, where we have pushed the last element, the last element placed, okay? And in the last we can say how many consecutive element we have placed, right? How many consecutive elements we have placed, correct? So this information help us to decide whether we place the next element or not, right? So this is the main thing you should understand. So you pause this video, try by yourself that before, instead of generating all the possible valid arrays, can we do something else, right? Let's suppose while building the array, what we can do, can we track these things? If we can track these things while building the array, then it will be easy for you. Yeah, it will help you to decide whether we can place the next element or not. If we can place the next element, right or not, that will be your decision, and then you can track this is possible or not possible to building the valid what do you call, the valid stable array, right? So let's try to understand how you can construct the array, okay? Let's come back to here. The very first thing that what we should do is how we'll construct. So we'll say construction of the array, okay guys, the construction of the array, okay? So let's try to think about this thing. This step is very important. So let's imagine building the array, right? If we will take the very first thing is that let's start with an empty array. So if we'll take the empty array like this, right? Now we can place either, what will place, 0 or 1, correct? So what is the option? So we'll say, okay, let's go with the option 1. So let's think that we will place 0. If we'll place 0, this array will become like this, correct? Now how many zeros are left? Now zeros left is 1. So we can place another 0 because limit is 2, right? Since the limit is 2, right? So we can place another 0, right? So let's do that. If that is the case, put one more 0 like this. So now consecutive zeros is how many? Total consecutive 0 is 2. So we'll say 2 here. So we cannot place another 0 here, right, after this. So the thing is, we can say, so we can't place another 0 because 0 thing is done, right? So what next? Next we must place 1, right? What next? Next is place 1, right? So how will you place? You'll say already we have 0, 0. Now we'll place 1, like this we can say. So these form are valid arrays, right? Similarly, if this is the case, we can say this is your valid array that we have already seen. Similarly, you will think that, okay, start with the empty 0, right? So you will add it here. Then you will take Okay, place 1. What you will do? 0 1 you will do. Then you will think place a 0. Then you will say okay, 0 1 and 0, right? So this is another valid one that we have already seen, guys, right? Similarly, you will add one more like this, 1 0 and 0, like that we have seen here, right? Same thing we will do here again and again. Until that, we'll keep finding the possible things, and we can do that. What is an intuition? Let's think that. Intuition. Okay, so at every step we have two choices, right? At every step we have choice 1. What is the choice 1 and what is the choice 2? I think you understood, right? At each step you have to two choices you have to choose. Either you place 0 or you place 1. Only these are the choices you have, right? If you place 0, but only if, but only if, when the remaining 0 is greater than 0. Can we say that, guys? Only if the remaining 0 is greater than 0. Correct? And there is another condition, and I forget that to write. And consecutive zeros, right? Consecutive 0. It should be less than limit. If two thing is there, right, this thing and this thing, only you can place the 0. Correct? If only if the remaining 0 is greater than 0 and consecutive 0 is less than limit, right? Now let's think that about the placing 1. What is another choice is there? You can place 1 only if, right? But only if, similarly we can say, if the remaining one is greater than 0, right? And consecutive ones is less than the limit. The same thing that we have saw there, right? The same thing you have to do here also. Only there is two choice. So this natural activity leads us to recursion with the memorization, right? Memorization we can say, not memorization. Memorization, right? So the concept comes here is that is called the recursion with memoization, right, guys? Like this. So this recursion with memoization gives you nothing but what? A form of dynamic programming. It's a form of dynamic programming, right? So let's try to understand here once again. What I'm trying to say, that we have some choices we have given. So at every steps you have to two choices you have to choose, either this or this, where either you will place 0 or you place 1. You can place 0 only if the remaining 0 is greater than 0 or consecutive 0 is less than limit. The remaining one, and you will place 1 only if remaining 1 is greater than 0 and consecutive limit is less than this limit, right? Consecutive zeros is less than what you call consecutive ones is less than limit, right? If these two things happens, so you have to choose at every step that you will place 0 or 1. And this concept, this naturally leads us to the recursion with the memoization, right? And this concept is nothing but a DP concept, right? Let's try to understand the DP here. Let's think that we have given, the very first thing is we have given our DP states, right? What will be the DP steps? So we know that our recursion function, right, needs these 4 parameters, right? are recursion function needs. What are the things they needs? Needs 4 parameter, right? What are the parameters are there? If we will create a DFS function, right, the very first thing we need is remaining zeros, then we need remaining ones, then we need is last placed, where it placed, and the consecutive count. Okay, so these 4 things if we can have, right, then we can define the our DP state. So this uniquely define the state of the problem, right? So to avoid the recomputation, we store the result in a DP memoization, right? We will use only to store the result. Okay, guys, let's try to understand the code that you will understand, right? But the thing is, in the DP, this is called a DP state, right? So to define the DP state, right, our recursion function needs 4 parameter. The parameters are what? Remaining zeros, remaining ones, last placed, and consecutive counts. And these results will be stored in a result that is called the DP memoization that we will see in the code. So as till now, we try to think that this DP problem will work and will use this approach, right? That we are thinking, right? So this intuition, that is the recursion intuition, right? We thought that the most natural idea is use recursion, where we have to place either 0 or 1, right? So we were trying to place 0 or 1, and we want to track some numbers, some of the things, right, like remaining zeros, remaining ones, last place, consecutive counts, right? So we are trying to place either 0 or 1, and we are also trying to track these 4 things that we have talked about, right? But the problem is that these I tried the code and I found some issue. Only one test case was not working, but 699 was working, and 670 total cases was there. So it was not working because I gone through to understand that this recursion creates a huge state space, right? Let's suppose what is the worst case will happen. Okay, so the worst case state is, let's suppose if we have some input, right? Suppose we are giving the input 200, 200, and 2, right? Or we can say, if we multiply all of them, these 4 things we have behind. So let's suppose 200 into 200 into 200 into 2 into 200, right? If these all will give you approximately 16 million, right, data, right, the states we can say. Okay, so even with the memoization, right, that we are going to use, right, the final test case cause the time limit, TLE, time limit, exceed error, right? So we need a better idea. So what is the idea? Let's try to understand here. Okay, so what we are thinking that, right, we can call this as a optimization idea. Okay, when you will talk about this optimization idea, let's suppose you are in the interview, right, and you are running with the code and some test case is not working, like this case, right? So what you can do is, I can provide that code. I have already written the code. I can put into the comment. Okay, not worry, you can ask me, or I can put there. I will write 2 things: the working code and the this code, okay, that I will put. So let's think about that. The very first thing is that the optimization idea. Okay, so instead of tracking how many consecutive elements we placed, we think in terms of placing blocks of numbers, right? What I'm trying to say. So instead of tracking how many consecutive elements we placed, we think in terms of what? block, placing block, we can say placing blocks of the blocks of we can say blocks of numbers, right, that we are talking about. Okay, so instead of tracking how many consecutive elements we place, we think in terms of placing the blocks of numbers, right? For example, for example, if the limit is 3, okay, so instead of building, right, so instead of, we can say, building, let's suppose we can build 30 and 31, right, we can build. So instead of building this, we think we should think like, we think of it as, or we should think something like that. Let's suppose the block of 3 zeros and the block of two one three ones, 2 zeros and 3 ones. Can we say that? We can think that rather than this one, we should think like this, right? So this allow us to remove the consecutive dynamic or dimension thing, we can say, right? What I'm trying to say, we can say this will allow us to remove the consecutive count, yeah, consecutive count, we can say, right, dimension that we were seeing above, right? The first approach we were seeing completely. Okay, so we can say like this. Okay, so the very first thing that we should use the in the terms of blocks, not in the terms of the consecutive things, right? So what will be the dynamic priming up and DP state now according to this approach, right? So DP state, let's suppose we define 2 DP tables. Okay, we define 2 DP tables. What are the tables are there? Let's call DP at, let's say DP0, we say DP0 at I and J, and DP1 I and J. Two things we can take here. Now let's DP0 and DP1, we have two things. So arrays using this I is 0 and J is 1, means we can say is DPIJ, right? This is the array, right, using I zeros and J ones. Okay, both should be having ending with 0, and these zeros and ones ending with 1. Okay, so if ending with 0, we'll put here. If ending with 1, we'll put here. So this separation is important because the limit constant depends on the last element, right? What we can say, because this separation is very important because the limit constants depends on the last element. Okay, so what will be the base case? What will be the base case, right? The base cases are very important to understand. If we have the array that contains only zeros, right, either 0 0 0 0 0 like this, right, we have. So these are valid only if 0 limit is less than equal to the limit. Can we say that? If it is less than equal to, then these are valid. So how we will initialize? So we initialize, I will initialize the DP. We'll say DP at 0. We'll say I and 0 is 1, like this. for all I should be less than limit. Like this we can say, right? Similarly we'll say dp at 1, dp1 we can say at this is 0 and this is j, right, equal to 1. And we can say for once, and this is for all this one, right? Means this is a similar thing we can say if the limit j limit is less than equal to the limit, like that. Okay, I hope you are understanding. Let's try to understand the dp transition, right? dp transition, what is the dp transition here? Okay, so now we fill the dp table, right? So once you will start filling the dp table, right, it will fill the dp table, right? The case one is what? This is to fill the dp table, right? So case one is the array ending with 0, that we have seen. So to end with 0, the previous element must be 1, right? To end with 0, to end with 0, previous element must be 1, correct? So then we append a block of zeros, right? How? See the possible blocks. We'll say 1 0, 2 zeros, 3 zeros, like this, and so on till the limit, we can say limit zeros. Can we say that, right? So we can, how we will compute then we can compute, if we'll write like this, then we can compute like this. Let's see how. We'll say dp0 at I and j, right? We'll say plus equal to dp1 at I minus k and j. Like this we will compute. What is k here? Means for the 1 should be greater than equal to k and should be less than equal to limit. Means for all k which is greater than equal to 1 and less than equal to limit, right? Similarly, if we'll talk about the case 2 for array ending with 1, right? Means same idea we will do, not nothing different, only the thing dp at 1 is we have I, so I and j will be there. We have to fill it, right? How? Plus dp at dp0 at I, here it will become j minus k, like this. Means the same concept will be if the k is greater than equal to 1 and limit is this one, the same thing you will apply here also, right? So let's try to understand the code so we will understand what I'm trying to say here, right? Basically what we want our time complexity of the, we can say the 0, what is 0 you have, right? Then we can say the 1 and the limit. If you multiply all of this, then you will get something better. Let's suppose in the worst case itself also, right? If you are getting 200 into 200 into 200, let's suppose all are 200 200 200, still you are getting 8 million only, right? The 8 million data which runs easily with this limit. Okay, so this will work even for the space, right? For the space complexity you will use 0 into 1 only, right? So this will also get accepted. Let's go to the code, then you will understand clearly. Okay guys, okay, so the very first thing that we have given, the result should be we have to take as a mod, right? So 10 to the power 9 plus 7 I think we have, right? Yeah, 10 to the power 9. So we'll write 3030 and then 007, like this. For the 10 to the power 9 we have given 10 to the power 10 to the power 9 plus 7. This is what we have given. We have to take the modulo, right? So we have to take the mod. Then we know that we need two things, two dp space we need, right? So we'll say, okay, dp 0 we can say. So it will store all the ending with the zeros. So new, and this is also long we will take, and we'll take here is a 0 that we have given. Just take +1 to adapt it, and the 1 +1 here, like this. Okay, similarly we will create for long dp1, we call this equal to new long, then we'll say the 1 we can say +1, and similarly 1 +1. So ij we can put easily, right? The zeros and the 1. So basically this is 0, so this is also should be 0. Okay, the last we have to put is 1 only. Okay, so two things we will use here. Okay guys, so 0 and 1 we will use. Now what we need here, because we have to one pass we have to go, right? So we'll say, okay, let's go with the one pass. We'll int I, right? And I should start with a 1. This I should be less than equal to the number of zeros that we have given, that is 0 we have given, not zeros. And I limit should be less than equal to the limit. It should not cross the limit, right? And then I plus plus. Okay, so condition is inside, and the initialization and the increment thing is in the last. So we are good. So dp at 0 will first pass I, and this is nothing but 0 and 0. So we'll store all those value as a 1. Okay, similarly we'll do for the dp1. So we'll say int, not we say I, this time we'll say j is equal to start with the 1 itself, and j should be less than equal to what you call the 1 we can say, right? Not 0, this is 1 for all the ones. And we have to make the condition also. So the limit should be maintained, it should not cross the limit, and then j plus plus. Similarly we will do. Okay, here we'll say dp at 1, we will pass two things. It will be at 0, and all the j value will store nothing but 1. So we have to both as a, we have placed the value. Now we will find the transition phase we will come, right? Where we have to iterate for I and j. So int I will start at 1, then we'll go for I should be less than equal to zeros, right? And we have to fill actually the table, dp table we have to fill. So we'll say I plus plus, and for that we will need two loop we need, right, to fill the array. Int j we can say start with 1, and j should be less than equal to the 1, right, and j plus plus. So these two loops you understand, right? Now we know that we have to do the sum, because we were seeing that sum we have to find. So initially sum will be 0, but we have to take a leap for k we have to find, right? Because we have to maintain a k that we have seen already, right? K should be greater than equal to 1, so we'll start from 1, and it should be less than equal to the limit, as we have already seen, right? And we have to maintain, and the value of k should be less than equal to here I, and k plus value we can say that, right? So very first we have started k equal to 1. K is a limit, it should be less than it should be less than limit, means between 1 to the limit, and k should be less than equal to I and k plus plus. Similarly we'll do for j also, but we will find the sum here. So we'll say sum is nothing but, we can find the sum, we call this as a sum, take some 0 we can take initially. Okay, so let's sum 0 first, because we have to separate. Okay, so sum 0 will take, so sum 0 we will update here. So you give this name also sum 0, right? Variables will be same. So sum 0 we have already initial value. Then we have to maintain the dp. What we have dp at 1, that we would need I minus k, that we know that. And this will be the same j. We don't need to do anything. If these two things is happening properly, right, you have to take the mod here itself. That mod we are talking about, right? So you got the sum here, right? Once this thing is done, you have to maintain dp 0, and you will write dp at I, and j is nothing but this sum 0. Okay, so this part I hope you understanding. Okay, similarly, let's create sum 1, start with a 0. Now we'll create a for loop. We'll say int k. Int k will start at 1, and the value of k should be less than equal to the limit, and we know that k should be less than equal to j here, right? Similarly, that we have done for what you call I, right? And k plus plus. I hope you are understanding. Okay, let's keep it little up. Okay, so these two things we have done. What is important now? We have to find the sum 1. So we'll say sum 1. Similarly, that we have found sum 0. So we'll say sum 1 what we have plus dp at 0 this time, say, because there we have to dp 1. So this I will be remain same. We will not touch anything, but j we have to say j minus k we have to do, correct? And once these are done, we will take the mod like this. Okay, so you will find the sum 1. So this is called dp1. You will say I, j, and you will add here is sum 1. Okay, and here you need to return, means when you will returning, you know that that is integer long we have to, right? So we have to take into integer, right? You have to typecast. So very first we know that we have dp, we have dp at 0 we have, and this is nothing but 0, 0, and another we have is 1, correct? Similarly, we need to do plus dp. We will pass here 0, this is 1, dp 0, dp 1, yeah, and this should be 1. Once these two sum you have already done, you have to take the mod again like this, and you will return it. Okay, so just you are doing the computation, because once you are done with all zeros and all ones, you have to do the count and you will return it. Basically we are binding the result. Okay, let's submit. Let's check any error is there. Okay, so we got dp. Let's try to think. Okay, I think that this is a conversion error. What we need, this we need long here, and similarly we have to define the long here. Okay, now let's try again. Yeah, working fine. Let me submit. So working fine. Okay, so basically we need to convert into the sum, what do you call, let me increase it. Okay, so basically you have to convert into the long, and then you have to uh, take the mod, right, in both cases. So very first we have taken two things we have taken, guys. We have taken dp0, dp1 at line number 4 and 5, and then we have initialize dp0, dp1, correct? And then we start line number 15 and 16. Along with that, we need to fill the array, right? To fill the array, we have to find some 0, some 1, and at the last, that we already store the dp0 and dp1. We have filled the table, dp table, so we have to sum it and you have to return it back. Okay, so that's all I have in this video, guys. The takeaway is that the biggest insight in this problem we found is that instead of tracking the consecutive elements directly, we should think in terms of adding the block of size 1 to limit, and this removes an entire dimensions from the db state and makes the solution very efficient, right? So if this explanation help you to understand this problem clearly, please like the video, subscribe to the ExpertFunda, and share it with your friends and prepare for the coding interview. I'll see you in the next DSA coding rounds, okay, or the questions or solution we can say. So if you are struggling with the DSA preparation, or you want to be a backend developer using Java and system design, you can join my online classes. And that's all I have in this video. If you have any inquiry, please ping me in the comment box, or you can join through the WhatsApp. That's all in this video, guys. Thank you, and keep watching, and happy learning. Happy
Thank you
coding.
guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.